In our next example, we want to consider radioactive decay. That's when your growth constant K is less than 0. So this would be any kind of carbon dating. That would involve radioactive decay. Also, decay of a drug in the body. So the body would remove that according to radioactive decay. So K less than 0 means that your function Y is decreasing instead of increasing. So let's look at carbon-14 dating, which has actually been used to date manuscripts in the New Testament. So carbon-14 has a half-life of about 5,730 years. So half-life, what does that mean? Well, that means that after 5,730 years, you've got half as much as what you started with. So in other words, our y of t is y0 e to the kt. So if you plug 5730 in here, you're going to get half of what you started with. You're going to get 1/2 of y0. So if you start with 1,000 grams of carbon, you're going to have 500. That's what half-life means. So we got a parchment manuscript that's found to have 79% of its original carbon-14. What is the age of the manuscript? What is the age of the parchment? So this could be, for example, New Testament manuscript. We want to date it and see if it's the earliest manuscript available. So while we start with our law of natural growth, y of t is y0 e to the kt, and y of 0 is always equal to 1 with carbon dating, which is 100%. So it starts with 100% of the carbon. Okay? And then what? Well, we're going to use that half-life to get our constant K. That's the only thing that we don't know here. So we do know, though, if you plug 5730 in for T right here, which is also right here, so that's e to the K times 5730, which is the same as e to the 5730K, that's got to equal 1/2 or 0.5, right? Half of the carbon that you started with, half the amount that you started with. So now we have to solve this equation. So we've got the exponential isolated. We take logs on both sides. So natural log e to the 5730K is natural log of 1/2. These guys cancel. We just got 5730K left is log of 1/2. Now divide off that 5730. So your K is going to be log of 1/2 over 5730, which is about negative 0.000120968. So I use 6 significant digits there. So now we can take and plug that back in here for K and update our original equation. So now we know that y of t is e to the negative 0.000120968t. So now what? Well, we want to find the time, t here, that gives 79% of the carbon. We know the time that gives 1/2. That's 5,730 years. So it's not that old. So how do we do that? Well, we're going to take our updated equation, e to the negative 0.000120968t, and we are going to set that equal to the 0.79, the 79%, always as a decimal. And now solve this for t. So, well, we've done this lots of times before. So undo an exponential with a log. These guys cancel. So we just got our constant times t is ln of 0.79. Divide off our constant in front on both sides. So t is log 0.79 over negative 0.000120968. And that is approximately 1,948.6 years. So that would put it about 70 AD approximately. It's 1950 years. So that would actually be about the time of the early New Testament manuscripts. So this would actually be a very early manuscript if this parchment contained New Testament manuscripts. So that is pretty cool. So, all right, why don't you try the next homework problem? You should be able to do that.